Hello everyone, welcome to this video where we're going to be looking at how we can define slope diaphragms. So we're going to be using rigid diaphragms for this application. We have an example model that we're going to be working with. And it's important to understand the nature of rigid diaphragms. There's a few different types of diaphragms in S-Frame. If we go to the panel element tool, we can see that we can define them here by just drawing in a panel. And they can be defined as either rigid diaphragms, which will constrain the joints along the edges or within the edges of that panel as a rigid set in plane only, so in the plane of the diaphragm. We also have a general diaphragm, which is used if we want to constrain the edges, constrain joints along a single plane. Regardless of the extents of our actual panel, it will constrain all those joints within that plane as a rigid body or a rigid set in that plane. And then we have independent diaphragms, which can be helpful if we have general diaphragms at the same elevation, but we want to distinguish the two of them. For example, if we had two towers at the same elevation, but they weren't necessarily coupled together in their movements. I'm going to be using the rigid diaphragm approach here, and what I'm going to do is I'm going to draw a diaphragm on this sloped portion of the roof. So using the diaphragm tool, the panel element tool rather, I just simply left click on the panel type I'd like, and draw it in, just as you can see here. So I'm drawing it in at a slope, as we can see. And that's pretty much all. Once I close it, you can see that it's created that rigid diaphragm for me. I can also verify the diaphragm nodes at the bottom of the screen here by toggling on this option. And I can see these pink lines going from the diaphragm mass joint, which will actually generate, to the constrained joints. And notice that it only selects those joints that are within that plane and along the edges of that panel as well. Before I get any further, I do also want to generate my rigid diaphragm mass joint. This will come in handy later on. So I'm going to go to the Edit menu, Analytical Model, and just say Generate Rigid Diaphragm Mass. It's letting me know, because I didn't assign any thickness to my panel, it's going to apply this rigid diaphragm mass at the geometric center, because there is no center of mass if we don't have a thickness. So I can just click the OK button, and we can see it's dropped in this joint right at the panel center there. Which we're going to be using in just a minute. So one important thing to note when we're working with rigid diaphragms is that by default, their stiffness as a rigid diaphragm, those constraints are with respect to the XY plane of that panel coordinate system. Which means here, by default, it's going to actually align with our global coordinate system. And you can see here the orientation of our XY plane of our global coordinate system is not in line with our panel. But we can actually rotate the joints within our diaphragm by using the joint displacement direction and assigning a specific UCS or user coordinate system to those joints. So perhaps the first step that we can do is we can actually go in and define a new user coordinate system using the user coordinate system tool. And then I left click on this tool here. I have this option to define a user coordinate system using the 3-point method. I'm just going to left click on this option, and this allows me to essentially define the new origin of my user coordinate system, which will be my first click. Then the second click will determine the direction of my user coordinate system's x-axis, which will be the second click. So it goes from the origin to the x-axis here. And then the third click will be the orientation of my user coordinate system's y-axis, which will be right here. And you'll notice here it's now created a user coordinate system at that location that is centered on that origin. The x-axis is aligning with the second direction that I defined, and the third direction defines the local or the user coordinate system's y-axis. And the z-axis can be found using the right-hand rule. Now I could save this UCS, which I'm going to do here. I'll click Save UCS, and I'm going to call this Roof Slope. And if I wanted to, I could even make this my global coordinate system if I had a good reason to. But I'm going to keep the global system as it is for now, so that I can actually easily toggle between the two. So I can see here in the UCS dropdown, I can toggle between global system and roof slope. One thing worth noting here is that when we have selected a user coordinate system that perhaps isn't oriented with the same angle of rotation as our global coordinate system, all of these predefined views in the aerial window will be with respect to that particular coordinate system. So the top view is looking down at the user coordinate system. The active system is looking down at the XY plane of that user coordinate system that's currently active. I'm not going to worry too much about that right now, but what I do want to draw our attention to at this point is the Joint Displacement Directions tool. So using this option here, we can define the joint displacement direction and basically rotate the coordinate system of each joint in our panels. This allows me to select a UCS, which is already pre-selected, the roof slope UCS, the angled UCS that I want to apply. And now I can go through and I can just change my orientation and left click and apply this to all the joints that I wish to rotate their coordinate systems. So now we can see what that looks like. Maybe I'll just change back to my global system for my view. And we can see that the UCS has been assigned to these joints, so those joint coordinate systems have been rotated. And more importantly, for a rigid diaphragm, the orientation of the XY plane of a rigid diaphragm is now in line with that sloped roof, rather than in line with the global coordinate system's XY plane, which happens to be the horizontal plane. So you may want to consider doing this if you're working with sloped roofs or sloped diaphragms. This can certainly help you get a more accurate result.